no shadows required. Okay, so we're gonna use the basic laws, and we're gonna do more stuff with them as well. So here's the thing, if you have two separate functions multiplied together, you can follow this rule. So what it is we're gonna define this, let's say this one's f of x, and this one is g of x. So what we would do is we would find the derivative of g of x, multiply it by f of x, and then add the original g of x multiplied by the derivative of f of x. Okay, so it's like one original and the other one's derivative. And then we add those two things together. Okay, two different ways of doing this. We can simplify before differentiating. So we're just going to go ahead and we are going to multiply those two things through. So I'm still using the basic, like I'm still using the original function. So this is going to be 2x cubed minus x to the exponent 7 plus 2 plus, no, that's a subtract. Subtract x to the exponent 4. Not very pretty, but very, very doable. So it just helps my brain if I put them in order of degrees. And this, you may not need to do this, but I always definitely do. Like I just put them. So step one, you could just multiply it out. The reason why this wouldn't be helpful is if they're really big and ugly multiplying, you don't have to do that. But let's go ahead and differentiate using yesterday's rules. So we're going to look at each one of these. So I'm going to look at the first term here. What's the differential of this one? The derivative, that's what I'm looking for. The derivative of this one. The 7 comes down in front. So this would be negative 7, x to the exponent 6. And then we're going to look at this one. So that's going to be
negative 4x cubed?
Yeah. And then this one?
Plus 6x squared?
Mm-hmm. And then this one, 0. Right, so do I need the add 0? No, but I'm just going to write it just so that we're comfortable with it. So this one is f. X, negative 7x to the exponent 6 minus 4x cubed plus 6x squared. Okay, so we know what the derivative is. We just found it out by expanding and then multiplying. And again, that's a great strategy if your functions aren't too complicated. But now we're going to use the rule for product of two functions. So what I like to do is I'm going to define them. Maybe I'll call this one kx and this one gx, just because I can. So I know that the kx function is x cubed plus 1. And now I'm just going to go ahead and do the derivative of it right off the hop. I'm just going to go right ahead and do the derivative. So this would be 3x squared plus 0. So I don't have to do anything there, right? 3x squared. Now the g of x function is negative 2 minus 4 x to the exponent 4. So the derivative of the gx function, this derivative is 0, and this one is going to be a negative 4x cubed. Everybody okay with that? Easy peasy? All right, I like to do those up front first, kind of like my side note off to the side. So it says that if I want to find the derivative of the function, I'm going to take kx and I'm going to times it by the derivative of g of x, and then I'll take the original function of g of x and multiply it by the derivative of k of x. So you always have one original and one derivative. You're never multiplying two originals together or two derivatives together. It's always kind of one of each.
Semi-conservative, conservative,
Sure.
like the buyer and then.
Nope. See, I already screwed it up. So this one's going to be negative 4x cubed plus g of x, which is 2 minus 4x to the exponent of 4 times 3 squared. So the nice thing about this is well, it's almost the exact same. You're breaking a binomial down into two. So we're going to have negative 4x to the exponent 6 minus 4x cubed plus, I'm going to put this in brackets because I know there's going to be a negative in there somewhere. So I'm just going to do my multiplying and put it inside of brackets. So I'm going to have 6x squared minus 12x to the exponent 6. Nope, I didn't do that right, sorry. That should be 3. Right, this times this is just 3. All right, so now we are going to combine like terms. And this one,
Negative 7x cubed.
yeah. How about negative 7x to the exponent
X
6? And then I'm going to have negative 4x cubed, and then I'm going to have plus 6x squared. And that's the exact same derivative as if we had expanded it. I'm not sure if one is any more work or less work, but in this particular case, but when the functions get a little bit more complicated, using this rule tends to be a little bit easier. Okay, we good? I can flip the page. All right. Like I said yesterday, we don't simplify a lot in calculus. We just kind of do the function, we do the math that we have to do, and then we just leave it. So when we look at this one, the first thing I'm going to do before I do anything is I'm going to convert that radical to an exponent. And that was part of your assignment yesterday. So I'm still dealing with the original. I'm still going to have them as two binomials. Okay, so off to the side, what I'm going to do is I'm going to say that this one's f of x and this one's g of x. So my f, well, I don't even need to rewrite my f of x. Let's do the derivative of f of x. So what's the derivative of f of x going to be?
6x squared.
Okay. So the 3 comes down in front, times by 2 is the 6, and we reduce it by 1 to give us the squared. This one has an exponent of 1. So 1 times negative 6 is negative 6. If I reduce this to a 0, x just kind of goes away. It becomes a 1, so we're all good. And if we do the derivative of the g of x function, right? That's it. So this is a big thing. Do not simplify. So I'm going to use my rules, so it's going to go a little bit faster. So if we're looking for the derivative of h of x, that's going to be f of x times by the derivative of g of x plus g of x times by the derivative of f of x. So always an original function, and then the second one's derivative. Like they're always opposite. You're never getting the same things together. So f of x is 2x cubed minus 6x plus 1. times by the g of x derivative, which we did off to the side. And we're just going to leave it there. So when I say do not simplify, this is where I want you to leave it. So F is an H. So this would be my answer. So looks super ugly. I don't really want to do anything with it, but it will work no matter what. I like the do not simplify things. They make my life a lot easier.
How I'm feeling today's and yesterday's assignments just gonna fly.
Yeah, I think like they just, like yesterday's was doing the basic rules. It's really quick. I think, you know, paying attention to making sure where you're putting things, that's probably going to be your hardest thing with this. But I find the rules kind of helpful.
And D2 sucked.
And I'm going to make you do D2 on the quiz because that was a really long one. You need to know how it works. And then you put that on the shelf and you use your basic rules for everything else.
Thing is, I don't know how it works. I just use the basic rules.
Okay? We can always work backwards if you know a little bit about it. Okay, let's do this one. So again, my j of x function, I'm just going to rewrite anything that is a radical as a rational exponent. So this one is a cubed root. So we're going to have x to the exponent 1/3 plus x. And if I say this one's my f of x and this one's my g of x, and this is just kind of side work here. Like this really isn't required or technical. Like you don't have to write this down. I just find it easier if I just look at this individually, go ahead and do the derivative. It kind of keeps me organized. So I'm going to have a positive 12 x to the exponent negative 4. I totally would have screwed that up probably if I was on a test or a quiz. Just because I'm reducing by 1, I'd always go negative 2. It's just a bad habit I have. And then this one's going to be 7. And then I've got my g of x function. I'm going to have 1/3 x to the exponent negative 2/3 plus 1. So again, the setup is for the derivative, and you don't have to write this out every time. This is not required to be written out. So it would be the f of x function times by the derivative of g of x plus the g of x function times by the derivative of f of x. You don't have to write that out every time, but I find the more, as you're learning it, the more you write it out, the more solidified in your brain it gets. And again, we're not simplifying. We're not going to simplify here. So f of x is negative 4x negative 3 plus 7x minus 1. That's supposed to be a negative 4. It doesn't look very nice. Not a hard assignment when you don't have to simplify, right? Like, you just got to put it in order and not screw it up.
Go up to the, we commit the murder and
There's no murder happening here. We're doing derivatives.
and then the pre-calc is a common cleanup.
Yeah, like pre-cal, we were so like, get it in the simplest form, show me all this different stuff. In calculus, it's a lot more like,
Relax.
it's a lot more laid back, but then there's all kinds of rules that you have to remember as well. Okay, so nothing too terrible with that. And again, this form is on your formula sheet. Do you have yours right in front of you, Snake? Is it? It's definitely on there? Okay, the next one is super confusing. And that form is on your formula sheet as well. All right. So here we go. So f of x is always your numerator, g of x is always your denominator, okay? And this one, order matters. The other one, order didn't matter because we were multiplying and we were adding, so order didn't matter. We could have flipped them around if we wanted to, but this one, order matters because we have a subtract sign, and that will screw everything up if you don't do it in the right order. And g of x gets squared on the bottom. So really what this is saying, I know we write it like this, but really what we're saying is g of x is squared, right? So the function g of x, that denominator is squared at the end. Okay. We are not going to simplify because this is going to be super ugly if we try to simplify. And we know the restriction, g of x can't equal 0 because we'd have a denominator of 0, then we'd have an undefined, and that would be just kind of a disaster. Okay, so this one, we know that our top function is the f of x one. We know our bottom function is the g of x one. So again, off to the side, I'm going to do the derivative of f of x. So that's going to be 6x minus 4. And I'm going to do the derivative of g of x while I'm here, and that's going to be negative 6x squared plus 9. Okay, so I like to do those right off to the side before I do any of putting it in the formula. So it's kind of weird, this is f of x and this is f of x. We should probably rename this something. Maybe we should rename this k of x, just knowing that that's the numerator. So we always start with the denominator first, the full function. So that's going to be negative 2x cubed plus 9x. Then we add in the derivative for f of x, so the numerator. Why don't we just do this? Why don't we call it n of x? And this one we can call d of x for numerator and denominator. That would be helpful. Don't know why I didn't think of that before, till right now. Sorry, I just thought it'd be helpful. No? Then it's that subtract sign. So if you started with the full function, the original function of g of x, that means you're starting with the original numerator function. So that's going to be the 3x squared minus 4x plus 7 times by the derivative of the denominator, which is negative 6x squared plus 9. And this is going to be all divided by the original g of x function, which was negative 2x cubed plus 9x. And we're going to square that.
And now we just let it all.
And then we stop there. We're not going to simplify. Okay. Terrible? Not terrible? I'd like you guys to do this next one on your own. I'm going to do it too. I just want to make sure we're all on the same page. You done? Nice. Okay, I'm going to show you what I got. Does it match? And then my big question is do you have f of prime? Nice. Allie, how'd you do?
D3 and D4 is
Good?
so good.
I accidentally put like the 2x on the bottom square, but
Yep, no, that's an easy mistake to make. Okay.
Allie, can you just like delete D2 and D1? Those suck. Yeah, okay, D1 is okay, but D2.
You're going to need to be able to do it.
Or I could just hope and pray that it's for median.
True story, yeah. Okay, so that's good. Now we're going to use this. We're going to determine the equation of the tangent line to this particular function at a particular point. So what does the derivative tell us? Which is the slope. So we know that f okay, so we need to find the derivative because that's going to give us the equation for the slope of that straight tangent line. So we're going to do that first. So we got to find the derivative of this thing. Easy peasy though, right? We just did it. I'm just going to do those right off the hop so that it helps. Uh-oh. I didn't leave myself a lot of room. Now, we could do a couple of things here. So that's technically the equation for the slope. We could go ahead and simplify it to get it nicer. It depends on how confident you are with your multiplying. It depends on how confident you are with your substitution. This question is really nice because the x is 1, so substitution should be fairly easy. So we could sub directly into here, or we could simplify. I'm going to go ahead and simplify. You guys do not have to do this. All I'm doing is I'm multiplying things together. 9x squared minus 18x to the x minus 5, subtract, we're going to add, it's my numerator, nice and easy. That one was nice and easy to do. My denominator, I'm going to have to expand it into two binomials. You just can't go ahead and square it. So obviously this is going to be 1 minus 2x cubed times 1 minus 2x cubed. So if I go ahead and do that, I'm going to have 1 minus 4x to the exponent 3 plus 4x to the exponent 6. If I do that, I think that should work. So my numerator is gonna be 9x squared plus, oh no, I can combine those.
Yeah,
Those are x squareds.
negative 15x squared.
Wouldn't it be 33? Wouldn't it be 33x squared because they're both positive? Like those will cancel each other out, but that should be a positive 24. It's rare that I get to do that. I always make the mistakes.
23x squared.
Okay.
What keeps on beeping?
Like the squeakiness? That's just a drawer on my desk. Okay, so that's the equation for the slope. We know that x is equal to 1. Because that's the point of tangency. So we're going to just dump that in. Tangent line. That's not good. So that's the slope of the tangent line. And we can go ahead and use our slope intercept form. Oops, sorry. Because we know m is equal to 33. We know x is equal to 1. We know y is equal to 7. So we are just trying to solve for, oops, b here. So 7 equals 33 times 1 plus b. So b is equal to, oh no, it was a negative 7. Sorry guys. The question said negative 7, so. Negative 40, so we have y equals 33x minus 40. That would be the equation of the line. So I think the thing that gets lost the most is that the derivative is actually the slope of the tangent line at the point of tangency. So if you didn't know that, it'd be really hard to understand where to start this question. But if you remember that the derivative is the slope, then you're good to go.